Well, hey there, guys. Welcome to SkyTour Livestream. This is Mark D'Antonio, and we are here watching the live DRACO cam. That is the camera's view right now. I know it doesn't look like much, but you have to understand the historical significance. This is the first time in history that we're going to see a live view of an asteroid approach and impact. Okay? First time in history. That's got to be cool, right? I think so. Now, there's so much to talk about with this. The impactor is going to strike a little bit later on. But one of the things that is neat to talk about is the genesis of why DART is being done at all. Okay, now, clearly, many of you know. Hi, Wayne. I see everybody out there. Okay, I see Donald, Andy Morrow, Dulay. How you doing? Richard Spencer, good to see you. I think I haven't seen you before. Maybe I have. Donald Kunzer, Daisy and Zoe Amethyst. I hope you got a hold of Lane. Okay. This is the DRACO Camera live feed from NASA that we're looking at right here. You can see the dual asteroid actually moving around there, and that's the thing that's interesting. It's a dual asteroid. Okay. It's an asteroid that actually has another asteroid orbiting it. And it's that smaller asteroid, okay, in the Didymos pair that is being struck by this impactor. Why would we do it that way? Because it'll be easier to see the difference in any orbit caused by this impact. If we look at the orbiting satellite, the satellite asteroid that's orbiting, if that starts to go, say, into a more elliptical orbit, we've succeeded. And this leads to the genesis and reasoning behind why we're doing this at all. Okay, the reason we're doing this at all, of course, is because someday we may have to worry about getting struck by an asteroid. Now, NASA has a list called the Sentry List, and it's a list of all objects that they find, asteroids generally, and comets. And until they study their orbits, they don't know whether it could be a threat to us. Now, some can be immediately discounted, right? But some don't. Some might need some type of additional work done, additional orbital elements, as they're called, to figure out. These orbital elements determine whether the asteroid is on an orbit that is dangerous to us or not. All right. Now, most of you realize and know I'm an astronomer. That's what I do for a living. I look at dots like this, okay? And normally in SkyTour Livestream, we actually look at beautiful nebulae and things like that. But tonight's an extra special night. And it makes sense because the SkyTour Livestream telescope in Arizona suffered a malfunction the other night, and we have a team going out to look at it on Friday. And so we couldn't have a better night to do this, because I would have been torn. I would have been torn between doing a stream showing beautiful stars and nebulae, and this. This is of historical significance. Hello there, Apache Ride. Welcome to you from Missouri. Thank you, Taryn Marie and Wayne. I said hi to you. Darren Cooper's here. Hey man, how you doing? Haven't talked to you in a long time. I have a feeling that this will be an interesting ride. There is no audio associated with this at the moment, so this is just the raw camera view from the onboard camera. It's the only camera on board the spacecraft, and we're seeing it. So, but think about how this all comes to be. The DART mission was launched some months ago, and it has to take a circuitous route. It can't just go straight there. It has to use gravitational assist and orbital dynamics processing to figure out how to get to this little tiny asteroid. And then it's going to be striking a littler asteroid going around a bigger asteroid. So it's a pretty strange situation, isn't it? But think about this. If we can make this happen, if we can make that asteroid get slightly nudged, then it means we have a future potential way to avoid disaster in the future. After all, extinction level events occur when asteroids strike our planet. So that's not good. Not good at all. And that's something we want to avoid, you know. So, again, this is the DRACO Camera live. And this, of course, is on the DART mission, the dual asteroid, what am I thinking? Redirection, dual asteroid redirection test. Holy cow. I think it's because I'm only doing 4 things at once. If I was doing 6, then I certainly wouldn't remember. But I'm just going to write that out so you have it on the screen. Now, because there will be some time that passes between now and then, I'm not going to sit here and talk the whole time. I'll disappear for a little while and then I'll come back. But it's going to be running just so we have it all here and see it. Hello, Suzette Bavier. How are you? Yes, please don't forget that thumbs up really is helpful to us. So, again, here's what we're looking at right here. This is the DRACO Camera live for the DART Dual Action Redirection Test mission from NASA. And this is, again, first in history. Michael Galea, how are you? Yeah, Mike C, what's going on? Good to see you. Good to see you indeed. Yeah. So, as I said, it's not as exciting as our telescope view right now, but it's certainly going to get more exciting as the evening wears on here, as the next couple hours goes by. I think I'll check the time. I think we're looking. I think we're looking at a 7:30 or so impact time. And just so you know, this object, this satellite, is moving quite fast. I'll get you all those details in just a little bit. I believe it's like 15,000 kilometers per hour, actually. So that's pretty fast. It's, if you think about it, it's somewhere in the neighborhood. It's a little slower than the orbital speed of the ISS, and that's going 17,500 miles per hour. I'm fine, thank you, Suzette. Legless Lex, good to see you. Well, Legless says, I was actually wondering when they announced it if we're going to be able to see it. Yeah, there it is. That's actually the DRACO camera. As I said, you see it right there. It's the only camera on the test vehicle, so when it hits the asteroid, it's going to be done. Because it's not like the Rosetta mission where they dropped the Philae lander onto the asteroid Churyumov-Gerasimenko or Comet 67P a few years ago. Okay, there we had the Rosetta spacecraft circling the asteroid, and the comet, I mean, and then the Philae lander went down. And of course, because of such low gravity on that comet, when the Philae lander hit, it was supposed to fire these bolts into the ground to hold it there. And what ended up happening was 2 or 1 of the 3 is functioned, the others didn't. So that it knocked it down the ground, and it was like it had a springboard. It went bling, and it bounced off, went up several kilometers in the area around the comet, and then came back down and bounced several times before it came to rest. Interestingly, those bounces didn't destroy it because there's so little gravity, it was moving so slow. So it was a slow motion, oh my goodness, and that kind of thing. And then, of course, it smashed into a crevice, which is the worst possible place for it, because where it landed, it only got some brief glimpses of the sunlit area around the crevice, and that was it. Hey, Michael Klagus. You know, Michael Klagus says, it would be cool if they nuked it. Yeah, well, guess what? If they nuked it, oh my. Let me talk about asteroids. Asteroids you think of as rocks, okay? And when asteroids are rocks, then nuking it would break it up into smaller rocks. But how about this? Many asteroids, like Bennu, for instance, the OSIRIS-REx target, okay? Many asteroids like that might not actually be rock. They might actually be lots and lots of little rocks that just happen to gravitationally come together in space. More like gravel piles that are just mutually gravitationally bound to each other. So they might be frozen together, like when you have two rocks that are in space and they collide with each other, a little bit of heat's generated, and if it's slow motion, they stick and then they freeze that way, and then more come in and stick and stick and stick, and so they make this congealed pile of gravel out in space. That's something that would be pretty catastrophic with a nuke, right? Because it would blow that thing to pieces, but then where are those pieces going to go? Everywhere. So an asteroid chunk that wasn't going to hit us might actually be more dangerous to us at that point. And as I mentioned earlier, the Sentry list, the list that they create to put dangerous objects on before they calculate their orbits and find that they're not dangerous and then remove them, that Sentry list would be populated by millions of objects, okay, if they were actually on a trajectory that could have been dangerous. The largest ones would stay in the Sentry list. The smallest ones would get dropped off pretty quick. So, and when people say, and people joked about Space Force, when people joked about it, what they failed to realize was that Space Force was created not to put Marines in space. Okay, it might be a poor choice of name. It should have been something like the Space Protection Agency or something like that, because it's really all about protecting us. It's about protecting satellites in low Earth orbit. It's not about anything to do with managing the spy satellite network or anything like that. It's actually more of a civilian thing. The space, I inquired because I was actually looking at potential work within Space Force at one point. And when I realized what it was, I was like, wow, this is so cool. Space Force is this organization designed to protect the satellite environment of the Earth. Now, the satellite environment of the Earth consists of many, many other satellites orbiting the Earth, right? Well, those satellites, of course, are extremely vulnerable to solar energy. Oh, look, I just got bigger. I'm getting bigger. Oh, no. Okay. I'm red with something, right? Anyway, when the satellites are subjected to, like, solar flux, that is solar wind from the sun during active periods of solar activity, well, then they can be damaged. So we need to have mitigation protocols. What can the satellite do to protect itself? Is there a way that satellites can protect themselves? Can we protect the satellites? Or as Captain Kirk might say, could we protect satellites? I don't know. Spock, you tell me. Okay, we don't know that. But the fact of the matter is, this is something that we have to care about. All right? So Space Force is going to protect the near-Earth satellite environment. It's also going to make sure that junk up there is dealt with appropriately down the line. Right now, we don't have a vacuum cleaner for Earth orbit. And there are literally millions of pieces of space junk up there. Now, you might say, but wait, there's only about 5,000 active satellites. That's true. That's very true. But there are many more defunct satellites, and some satellites have collided and split apart, and then all those little nuts and bolts and pieces of aluminum foil and thermal coverings have all spread to the Earth orbit areas, and some of it re-entered the Earth's atmosphere, and some of it went into orbit around the Earth, so it was more of a cloud of debris also around the Earth. You can imagine the day would come when we can no longer protect our rockets going up into space from debris impacts, right? That could happen. And if that was to happen, well, at the speed a rocket goes up, many times the speed of sound, and then it travels up to 17,000 miles an hour, you can bet that eventually the rocket can impact something that could damage it. And so we could end up trapping ourselves on our own planet just by putting up too many satellites. Did you ever think of that? That's pretty crazy. That's pretty crazy. Hey there, Ronald, Earth Radio. How you doing? Where's Rosie, the Jetsons maid? Right. See, he didn't say Rosie, but I know that was, yeah, Mr. Jetson. You know, remember Rosie? Yeah. Hey, Ricardo, how you doing? Neutrino, what's up? Yeah, Brandon Lee, how you doing? The main event, I think, is around 7:30, approximately. And I will confirm all times anyway. I'll step away from time to time because we will be waiting for this to occur, waiting for everything to happen here. All right. And I know this screen doesn't look too exciting, but trust me, this is the one you want to watch. You know, because there are. This is going to be the last thing that the satellite sees just before it impacts, and thus it'll be the last thing you see. Now, I think it was Daisy or Zoe asked earlier, when it strikes, will it destroy the system? Will the camera feed stop? Yes, it will. And that'll be the end of it, because it'll be done. You know? Hey there, Neo Smoke, how are you? Yeah, the Neo Smoke says, kind of dangerous tech when a bad person gets his hands on it and redirects one to Earth. Yeah, you know, that was, if you remember, that was the subject of a science fiction movie. Do you remember the name? These enemies were directing asteroids down onto the planet, destroying it. What was the name of that movie? If you don't know, I will tell you. Okay, the name of the movie where an alien race was fighting another alien race within their own solar system and dropping big asteroids onto the planet. It eventually heated the planet up and the planet was destroyed. What movie was that? I'll give you a hint. It's very old. Okay, so with that said, I'm reading quotes here. Oh yes, remember Salvage 1 with Andy Griffith? He was built a spaceship out of scrap, and his whole idea was to bring space junk back to Earth. That's right. That was a great little show. You know? Hey there, Jeremy Blaine. And Jeremy Blaine says, hey, the story is real. Yeah, well, who knows, you know? Actually, in all likelihood, that probably did occur. Ah, yes, Donald Kunzer got it. This Island Earth was the name of the movie. Yeah. Remember Exeter, the guy that was the head alien? He captured 2 Earthlings, and they ended up going to his planet, watched his planet die, and then they got the big mutants that came after the lady. It was actually kind of fun. Hi there, Rubiku. Is there a Twilight Zone episode like that, he says? I don't remember. I do remember the Twilight episode, or Outer Limits, where these aliens landed on a planet, were going to take over the planet. And they looked like they were going to be able to do it because they had all these ray guns and so forth. And then, like, I think it was a farmer came out to the hayloft, and their saucer was like this big. And they were tiny. It's like, oh, guess we underestimated the size of Earthlings. Something like that. And of course, the classic To Serve Man. Everybody knows that one, right? These aliens come to Earth, and they're 6 feet tall, and they say, we are here to serve man. We want to see man excel. We're here to serve man. I guess women didn't count, I guess, back then. And they ended up bringing all these Earthlings onto their spacecraft to go to the promised land of this new alien world where they'll get anything they want. Yep. And they gave a book which said, which translated to serve man. And it turns out that the book, when translated by the guy here on the planet that knew things, the guy on Earth that translated their language, what he read inside was astonishing. It was actually a cookbook. So, to serve man. Yeah. With shallots in a cream sauce, with a cream brulee. I mean, I think that was an excellent episode as well. Yeah. And then Donald Kunzer says, well, he's given 3 of us. One was, of course, This Island Earth, and then Space Battleship Yamato, where the Gamelons were bombarding the Earth with radioactive rocks. Yep. Okay, hi, Sean Smith. And then he says number 3. Where'd it go? Uh-oh. I know it was here. I saw it. Well, I'll find it. But number 3 was another one that he had said. 2 was Battleship. Yes, Battleship Yamato, yeah. Ronald from Radio says Star Trek had one where people were in the asteroid and it was headed to crash into a planet. Right. I believe that was For the World is Hollow and I Have Touched the Sky. And that's the one where they had the pink sky. And that pink sky was, of course, the inside of the asteroid meant to simulate the sky. You know, and that old man said, "For the world is hollow, and I have touched the sky." And because you didn't come out from the interior of the asteroid, you stayed inside, and you didn't come out to the surface, but he did, and that was pretty interesting. So yeah, I mean, there's a lot of interesting asteroid TV shows. I actually wrote a book, a short story, which was Mark Eno, Asteroid Miner, and this guy was mining the asteroids, and it was all done with science, plausible science, and he had the only thing I deviated from was I actually allowed him to have an android helper that was a humanish helper, that's like the Boston Dynamics robots on steroids, so it could talk, it could converse, and it could do everything that a human could do, if not more. So it was probably 150 to 200 years ahead of where we are now. So it's cool. And then Uberku says The Expanse is pretty cool. And it's pretty detailed what it would be like growing up in low gravity. Yeah, The Expanse is another show where they actually do that. But if you notice, every single show, and I haven't seen one that really can get it right, every single show kind of avoids the issue of low gravity, don't they? When let's go all the way back to UFO, the TV show UFO, with Commander Straker and Moonbase, okay? Well, he's on the moon, okay? When they're on the moon, they're walking normally. There's no 1/6 gravity, right? Jump ahead to Moonbase Alpha with Space 1999, and they're walking around like there's no 1/6 gravity, and they kind of avoid that, don't they? And same thing with The Expanse, and they're walking in the ships. They're just, they're not floating and pulling themselves along, although they've showed some of that to their credit. But they have some kind of artificial gravity, and that's how they avoid it. It's artificial gravity. Shh, don't tell anybody. So it's pretty cool. Yeah. So it's pretty cool. And then what was that movie with Tommy Lee Jones? He built a Saturn V rocket in his barn. Was that called The Astronaut? Help us out, chat. Hey, Carmen. Hello. Welcome to the Dart Rendezvous stream. This is going to be pretty cool. I don't know yet when I have to get a better handle on what's going on, about in terms of when. I think it's 7:30 when this is actually going to strike. But there it is. That's the DRACO Camera live, looking at the target. DART stands for Dual Asteroid Redirection Test, and it was launched again. The whole spacecraft's just going to get smashed into the asteroid. Now, it's not a single asteroid; it's 2, and they're orbiting each other. Okay, one is smaller and orbiting, but they're still moving around a common center. Okay, and that's called a barycenter, that common center of motion. That doesn't move, that just goes in a straight line, but the other 2 whirl around it. And I think it's the smaller of the pair that's getting struck. And that'll allow them to see whether there's any kind of deviation to its orbit. And if so, it tells us a little bit something about what we can do in the future to protect ourselves. And I mentioned it before that the Space Force is actually tasked with protecting us and protecting the near-Earth satellite environment. So the Space Force will be partially responsible for building up a process and a procedure to counter any type of asteroid that may come in and threaten the Earth. And as such, Space Force is going to be something for the whole planet. It's not just going to be for the United States of America, because if a 10-mile diameter asteroid strikes in the middle of Siberia, okay, or in the middle of the Pacific Ocean, where the United States has no jurisdiction, the disaster is still the same for everyone on Earth. So I wish that we could actually work together on something like this. It's a very important thing to do, you know. So we've got some time. We're going to keep streaming, you know. If anyone has questions, put them out there. Hello, Stephanie Kerr. Yeah. Yes, and Stephanie Kerr says, but those two have been together for eons. Right. What one universe has created, let no other universe pull apart. I get it, right? But the fact of the matter is that in this particular case, I don't think it's going to be missed. One of the things that we understand pretty well is that the existence of life depends on a great many factors, right? Among those factors, it will depend on the ability of a body like a planet to have liquid water on the surface. Asteroids like this that have nothing but vacuum around them will not have the prospect of having liquid water on the surface. So from our limited understanding of the universe, notice I said limited, we don't know we don't know whether an asteroid could harbor life. So are we doing something wrong here? No. But are we doing something we shouldn't? I don't think so. This is a binary asteroid. It's two. Okay, one orbiting the other. So I think that's pretty cool. How that's working. All right. So it looks like we have 75 minutes to go, and this is the live feed from NASA that you're seeing here. So every once in a while they're going to come in and change a few things. Yeah, I tell you. While we're doing this, let me give you an update on SkyTour West. We had a malfunction of the computer out there. Actually, not the computer, the telescope. But it might be down to a connector connecting the telescope to the computers. And if that's the case, we're sending folks out there on Friday. Marianne and Tara are going out there on Friday, and they're going to examine the connectors and check them out. I'll be there telepresence. They'll be talking to me on the phone at the same time. And we're going to try and bring the system up and see if it'll work. And if it works, then we will have avoided a little bit of a bullet. But if it doesn't work, they are going to take the telescope and drive it down to Tucson, to Starizona. They're my go-to folks. They are fantastic. Starizona in Tucson, Arizona. They know how to take care of a telescope. So they can repair anything that might have gone wrong. I might have a problem with something called an encoder, but we're going to find out. And with any luck, we may be getting another telescope in there soon. And that's as far as I'll take that, because I don't want to say too much until we know for sure. In that case, that would mean our future goal here is to be able to broadcast from 2 telescopes at once. And I can do that. I'm sure I can do it. We actually have, we can look at the wide-angle view and then a close-up view of the same thing. Won't that be cool? So when people say, I wish we could get closer, or can we look at the planets? Well, this would afford us the ability to look at Jupiter's cloud bands, Saturn's rings and Saturn's moons, the moons of Uranus and Neptune, and then we'd even be able to see Pluto. So this will give us a chance to look at these objects in more detail. And that's not all it can do. It'll be able to look at nebulae in a way that our wide-angle view, which is a very fast machine, does very well. But if you want to see something a little bit you want to see something that's a little bit more, what's the word? A little bit more close up, then the other one is what we're going to look at. And now imagine seeing them at the same time. You've seen our panoramas of the Eagle Nebula, okay, and so forth. And the Eagle Nebula, right, that we've taken pictures of, is gorgeous. And you see the entire nebula with the pillars of creation in the center. Well, if we get a telescope that has a higher focal length, and we take a similar picture of that right next to it, well, then you can see the pillars of creation in the wide field and see the entire nebula. And in the other telescope view, you're going to see the pillars of creation dominating the view. Won't that be cool? And we can switch back and forth, put them both on the screen at the same time, so you can see one and the other while they're both building up and making a gorgeous image that can be sent up to the database. And speaking of the database, the data all the way up to the last stream on the 17th, I think it was, has been uploaded into a database courtesy of Robin Curtis. And that database is going to be prettied up, and we're going to make it available for you to search on at some point. I'm working out the best way to do that now. So, for instance, you come in and say, I want to see all the coolest nebulae that SkyTour has ever taken. You enter some search terms, and boom, you're going to get like maybe 100 or more results. Right now, we have almost 800 separate object images in the database. That's quite a lot, and that's just from the end of last year. Okay, so as you can see, we're pretty prolific. We're pretty prolific, doing some cool things. Hey Zadarak, how you doing? Yeah, actually, it's fine because some of you also noticed on the camera there was some diagonal streaking, and we're going to fix that too at the same time and get the entire system cleaned as well, if it has to go to Tucson, for repair. I don't mind either way. I prefer it not have to, because I was planning on coming out. I'm going out in November anyway for a week in the desert to cater to this and fix it if I have someone that can help me with it, because it's actually just a little bit more complicated. It's not a one-person job. In other words, it's a pretty hefty thing we got to disassemble. But yeah, again, this is gorgeous. Yeah. So these are, again, this is the DRACO camera, okay, that you're seeing on here, and then this here, okay, and we're seeing the asteroid as we're approaching it. And the asteroid's actually two asteroids. And in this view over here, I actually saw two objects for a period of time, but now there's only one, so I think it depends on the exposure settings that they're using. So we'll see what happens as they go forward. All right, Suzette. I'll be taking off for a little bit too, just to go eat some dinner. And Ronald says, how fast are they moving? Well, these asteroids are not out in the asteroid belt. They're actually, I think, a near-Earth pair. I'll have to get all that information. I can tell you how fast the satellite's moving. It's going to be moving about 15,000 kilometers an hour. That's pretty fast. So at that speed, it's going to strike this thing and obliterate itself, and it will impart just a little bit of what's called an impulsive force. Like if you take your fist and slap your palm, you notice how your palm goes down when you do. It just doesn't stay there. It goes down. Okay, that's because your fist is imparting an impulsive force. Okay, it's called an impulse. Bam, and it goes down. Okay, when you hit. Well, that's what we're trying to expect to see happen with this asteroid pair. When it strikes that asteroid, the asteroid's going to go down, but in space it'll just keep going. So it means that if it has a circular orbit, okay, oh, that's just great. Get rid of that guy. Spammers. Okay, that's how you know you've succeeded, when you start getting spam bots coming in. Okay, so if you see that thing going down like that in space, that means it's going to move, and if it's moving, it means it's going to change its orbit. So if it's a slight elliptical orbit, it should be maybe more elliptical when they're done. So they'll get to study the orbit and see if this actually happens like that. Hello, Marianne. I was just talking about you. Hey, thank you very much, Ronald, for getting rid of that. All right. So, in any case, if you look over here, you watch every now and then, you'll see there's two objects. And I think that we're looking, again, the DRACO camera is locked onto the asteroid, and it's going to be getting closer and closer. And if you look up in the upper left, it has it's 67 minutes and 2 seconds until impact. But you may not be able to see that, can you? So let me see if I can fix that. Just a minute. Now you can see it. Well, how about that? I guess I should have done that for you before. There we go. Now you can see it. Right there. Okay. 67. Well, once that gets off, yes. Right up there on upper left, 66 minutes until impact. That's really good. Yeah. All right. So, it's been getting bigger in the view as it's approaching, actually. And Ronald says, I was showing a movie on my channel, had one come up, and I did not see until... Oh, okay. Yeah. You know what? I have some wonderful mods here, and they actually get rid of things really fast. You know. So how you doing, Marianne? Good to see you. Yeah. Marianne, are you by your computer right now? Let me know. One second, guys. I'm taking care of something. Okay. Let's see here. About the truth of reality. That's the show that Ronald was showing, I guess. Pretty cool. Yeah, why'd that stop? Keep going. There we go. All right, so that said, I have a feeling, hey Charles Smar, I have a feeling that we're going to be in for some interesting time tonight. Again, I've said this before, this is the first time in human history where we've actually been able to see a live footage of an asteroid strike. Now keep in mind, it's between 3 and 4 seconds old. Okay, that's how long it takes the signal to get back to us from here. Hello, Cheryl, Texas. So that's pretty cool, you know. And I'm not sure, and Neutrino says, I wonder what it's made of. Well, typically, asteroids can be made up of, you know, some of the early components of the solar system, rock-ish materials. But as I mentioned earlier, sometimes asteroids strike each other and just get destroyed. But because there's nothing but themselves out there, mutual gravitational attraction can actually pull those particles together and form sort of a congealed mass. Because as they pull together, they hit each other. There's a tiny bit of heating, and any ice layers will melt momentarily and then refreeze almost instantly. So it'll cement particles together. And over time, you get this big cemented rubble pile. And so some asteroids are like that. And I mentioned earlier, Bennu, B-E-N-N-U, the OSIRIS-REx target. Bennu is a rubble pile. And if you were to like slap it with the hand of a god, so to speak, it would just disintegrate into lots and lots of little particles. Kind of like a snowball would if you slapped it and threw it in the air and slapped it. Some particles would be big, some particles would be small, and then you'd have millions upon millions of additional water droplet size or water molecule size pieces that come flying off it. So it's something else, you know. So this one's probably, it could be made of silicates, you know, silicon-based rocks and so forth. There could be some, well, we could have some type, possibly some building blocks of life in some ices that might be present, because this asteroid, of course, has been out there for billions of years, right? So there might be some hydrocarbons in some way on the surface that it might have received from passing by something else in space, or generated itself. It's possible. So I don't know. Ronald says, might be gold on there. Well, what you don't know about Ronald is he's a gold prospector, guys. Shh. Don't tell anybody. He's a gold prospector. So Ronald would actually be able to, you know, find gold out there. Yeah. Hello, Jeannie Young. Neutrino, that's actually a good analogy. He says, so it's all stuck together kind of like a Rice Krispie treat. Actually, yeah. Yeah, except instead of a sugary slurry, it's actually ices of various kinds. It's not just H2O ice. It could be carbon dioxide ice, you know, from the spare carbon dioxide molecules that are around. It could be ammonia ices. It could be methanol. There's a whole bunch of things that could be tied up in this asteroid. Again, this asteroid pair. So I can't wait to get this thing nice and close and just watch this. This is going to be just something else, you know. And you know that people there are just going to really, really eat this up. They're going to love this. Yep. Okay, Stephanie, go for it. Taste 444, how you doing? Have they filtered out other light sources? Just thought you'd be able to see other stars, be so far from Earth, glare, etc. Oh, that's a very good point. The camera is set up so it can view the relative brightness of the asteroid, but it isn't set up to show the blatant brightness around it. You have to open it up a lot further. You have to open the iris, the opening a little bit more. And I'm not sure whether we'll be able to see that at some point, because they do have control over that. But you're going to see this getting bigger and bigger, I suspect. And it is the one and only camera on this instrument, because think about it. They're going to destroy it. And there's a 3-second delay. But you're going to get a continuous stream, relatively. I don't know how many frames per second. You might just see like the last several, but I'm watching it change every half second or so. So maybe it's we're getting a frame rate that's every half second or so. So that's considering the bandwidth requirements. It's amazing that we're getting a signal from this probe that's really so far away. Yeah. Hey, Genghis, how are you? Genghis is here. Oh, yeah, the feed will be live on a number of channels. It's true. Yeah. This is the meat and potatoes one. This is the one that means it, right? That's the one that we want to see. I will say there's a lot of incredible stuff to see out there. No doubt about it, Let me just move this down a little more. Well, let's try that. Bet you that works better. There we go. Yeah. As you can see, time to go is 58 minutes. So in just under an hour, we are going to strike the asteroid. That's crazy, huh? Now let me tell you something. Remember the other project called NEAR? N-E-A-R. Do you remember that one? Do you remember that one? That's okay, Thace, of course. That one, that NEAR, N-E-A-R, stood for Near Earth Asteroid Rendezvous. And they went to an asteroid called Eros. Now, Eros is an interesting asteroid. It has a kind of a weird shape, okay? And Eros was the target of a satellite, a probe, and they wanted to call it or make it a soft landing on Eros. And the probe that landed on Eros was managed by the Goddard Space Flight Center. And the Goddard Space Flight Center was, of course, it had assembled a team of people. And one of the members of that team was a Catholic nun. A Catholic nun. And because she was an astrophysicist and an astrochemist. And it just so happened that little white-haired old lady was sitting at my dining room table upstairs. And we were discussing the Hubble Space Telescope years ago. And I did not know she was an astrophysicist. This is a funny story. And she came over here with another Catholic nun who was a member, a relative. And I met her for the first time. I was like, oh, hello, nice to meet you. Her name was Sister Mary Ellen Murphy. And Mary Ellen sat there, little white hair, very quiet and demure, didn't say a lot, very smiled a lot. And she said that she was interested in astronomy. I said, oh, well, I've got some gorgeous photos of the Hubble Space Telescope downstairs that have been taken. Would you like me to print you some in color? Oh, she goes, I would absolutely love that. So I disappeared for 40 minutes and I printed a bunch of these out. I brought them up and I sat down at the table. I'm talking to a little white-haired old lady. I didn't know any different. And I explained to her how these nebulae formed. I explained to her what they're made of and how they're emitting light. Ionized hydrogen, doubly ionized oxygen to make the greenish blue. Ionized hydrogen is the red. And I explained how white dwarfs work, and so forth, and how their mass had to be a certain amount and no more, because otherwise they might collapse further into a neutron star or explode in a special type of supernova called a Type 1a supernova. And she's nodding her head, wow, that's so exciting. Meanwhile, the other nun is laughing. And I said, Florence, why are you laughing? And she goes, she's an astrophysicist. I was like, oh my gosh. I had no idea. And that's why. So I was kind of embarrassed. And then Sister Mary Ellen just laughed and said, oh, it's okay. Because everything you're saying is not only correct, it's exciting the way you tell it. I was like, wow. I mean, talk about being okay with someone telling you what you already know and spinning it in such a way that it's a compliment. I thought that was pretty cool. Well, anyway, Sister Mary Ellen did pass away some time ago, and I contacted the OSIRIS-REx team that was going to land on Bennu, and I said, what are you doing, in tribute? Are you doing any tribute things with OSIRIS-REx? And they said, oh, yeah, we are, actually. If you have some images or recordings, we'll send them on a microdot and we'll send them out to Bennu. You go, really? Oh, how about microdot with the imagery from a woman who worked on the Near-Earth Asteroid Rendezvous project and was responsible for all the chemical results and handling of the spacecraft? And they said, that's a priority. So I sent them. And so Mary Ellen Murphy is now orbiting the sun and will continue to do so for about 1 billion years. I think that's pretty cool. Nice tribute, right? And I also worked with Douglas Trumbull, Academy Award-winning guy. He was a good friend, and he passed away recently. And his family is shooting him to the stars. And he's going to go up on a flight, and he's going up with Nichelle Nichols, Uhura, Jimmy Doohan from Star Trek as well, Scotty. And he will be released into space for all eternity as well. So I think that's a pretty cool thing. So let's see what's going on over here. Hey Drexy, BTW, how you doing? My dad wants to know thought of you. Best source to watch DART. Well, actually, this is the actual camera on the spacecraft, so you can't get any closer than this. But there's plenty of things out there that are that show it. If you want to see it in a different manner, you certainly could. There's no doubt about it. But we're doing it too. Why not? You know, why not? I think this is pretty cool. So I am pleased to welcome all of you here. And for those that haven't seen this before, it's a little bit different. Sky Tour live stream. Normally when we start up, you'll see this screen. Okay, that screen you'll see. And then we have the main screen, which actually shows our telescope up here, and then other things. And we have the telescope control system and the camera control. But tonight we're actually doing we're just doing this right here. Okay, we're doing the DRACO camera, which is on the dual asteroid redirection test spacecraft heading toward Didymos, which is the name of the asteroid, which again is a binary asteroid. It's two asteroids orbiting each other. And then they will collide and see if we can change their orbit a little bit. That would be kind of cool. That will tell us we can protect ourselves from asteroids should they ever hit us. And I am looking, and I think if you look carefully, you can see a couple of objects in here as opposed to just one. All right. Yep. James Dugan's here. Greg O'Brien, hey there. Jeremy Blaine, how you doing? Charlotte Realdis, how are you? What is happening is, Charlotte asks, please, what is happening? What is happening is this right here, the camera we're looking at is from a live NASA mission. This is a live feed from a long way away, millions of miles into space. And it's for the DART project, which is the dual asteroid redirection test. And it's two asteroids that are orbiting, and they're going to strike one of them with the satellite itself, and see if they can make it divert a little bit in its orbit. The purpose is to generate a system by which we can nudge an asteroid in the future if it becomes a danger to the Earth. This is something that is very, very important to do. After all, the dinosaurs were killed by an asteroid event which caused a major extinction event on our planet. And I think to understand the magnitude of what this means and what happened, let's go back 252 million years ago. Tell you what, we'll do it from here. We won't actually go back because I can't find my time machine. But what happened was the Permian period, Permian, the Permian period was an amazing period where there was lots and lots of life forms, a lot of ocean life. And during that time, there were creatures that would become mammals like us that were just coming into existence. And they started to dominate very quickly. And then what happened was that there was this massive extinction event which occurred and wiped out 98% of all the life on the planet. We were this close. Now, that particular extinction event wasn't from an asteroid, okay? It wasn't. It was actually from an Earth-based catastrophe, namely a massive volcanic eruption that occurred in what is now Siberia, okay? And what happened there was this lava flow that came out and put a cap over the land, okay? And then lava kept coming up underneath but couldn't get out, so it went sideways. As it went sideways through the underground permafrost areas, it began to burn and melt away ices and other carbon-based and organic materials that were in the soils as it pushed outward in what are called volcanic dikes. And it acquired billions, literally with a B, billions of tons of carbon dioxide. And when it got to the edge of the cap, it blew out on all sides almost at the same time and put many, many gigatons, billions of tons of CO2 into the atmosphere in just a very short time, a few days to a few weeks. What did this do? This ended up causing a major extinction because the temperature on the Earth rose 21 degrees Celsius in a very short time. When water is warm, ocean water is warm, it's harder for animals that are used to a certain temperature to survive, so they died. And the biggest deaths occurred among the phytoplankton, those little creatures that no one sees in the ocean that create the oxygen we breathe. They're the primary oxygenators. Look, we now see the two of them. Look. Okay, and they are the primary oxygenators. So when the phytoplankton died, then animals that breathed oxygen died, and the planet's temperature rise in the oceans caused many marine creatures to die, which caused cascading failures all across the ecosystems and niches. And so we lost 98% of life on the planet. Now, the things that survived that 2%, are the things that became the dinosaurs. And it's at the end of that Permian period, where that eruption had occurred, which killed off 98% of the life, that's when the age of the dinosaurs began. And it continued from 252 million years ago all the way to 65 million years ago. That tells you how successful dinosaurs were. That's really a successful set of species of all different kinds. That's a long survival history. Humans, on the other hand, we're at 4 million years. If you go back to Lucy, right, in Africa, Australopithecus afarensis. So, that said, we're looking at a very successful species that was knocked off by a asteroid strike. Now that species, all the species of dinosaurs, those were actually quite successful and quite diverse. So the diversity, even though they were diverse and could handle different types of temperatures, cold and hot, they couldn't handle the sun being blotted out because the meat eaters ate the plant eaters. The plant eaters died off when the plants died. That's from all the dust that the asteroid blew up into the air around the Earth. So, unfortunately, that's what killed the dinosaurs. So if that's going to happen again, all right, see, I'm a blur now. I mean, I'm all blurry. Ooh. Okay, there we go. Now, if that's going to happen again, then we have a very frail infrastructure right now. And we don't want to have to go through that. So in order to not go through that, we're going to have to make sure that we figure out a way around it if it was to happen again. And the way around it is to do exactly this. Make sure that we have a asteroid protection plan. And I'm going to try and make this a little bigger because there's some really neat details showing up in this right now. Look at, you can see the two of them. Look at them. See them? Here they are. You can just see that little one right there at the end of the point. See it? It's going to get bigger and brighter. So yeah. Hey there, Tim F. Hello, Matt Brooks. How you doing? Yeah. So if, like I said, if anyone has any questions, let me know. Daryl's not with us tonight. He's actually a little under the weather, so I don't know if he's been in the chat at all. Okay, Greg O'Brien asked, what will happen to the other asteroid? Well, probably nothing, but if this was, let's say this was an impactor with a sufficient mass, it could actually take that second asteroid and push it enough so that it go into a very tight elliptical orbit around the main asteroid and maybe spiral in and strike it at some point. But this is just a tiny little spaceship on an asteroid that's actually significantly more massive, even though we're talking about hitting, I think, this little one right there. You know, if we hit that little one, not much is going to happen. But it's just going to be amazing. I can't wait. I'm just so excited to see it. Can't wait to see it. Yeah. Yep. And we're looking at... There we go. And we're at 43 minutes away. Holy cow, 43 minutes. I'm getting so excited. I don't know what to do with myself. Cool. Charles Smar says Dimorphos completes an orbit around Didymos every 11 hours and 55 minutes. After the impact, that may change to 11 hours and 45 minutes. Right, because it's gonna push Dimorphos just enough to accelerate it in its orbit to possibly make it a more elliptical orbit, and so it'll go faster around Didymos. Thank you, Charles, for that information. Yep. So Donald Kunzer says, so around 7:16 EST. Yeah, if you look at that time, 42 minutes from now. Yeah, so it's 8:33 now, 18:33, 6:30. So yeah, we're looking at about just after 7:15 or so. Actually, just about 7:15. Yep. All right. That's right, Greg O'Brien. ERRT is Ronald Tovtar, who is the master of operations over at his radio station on Mixlr. Ronald, you have a wrench. Cut up a link to your Mixlr site if you can. Get some people to come on over and listen. You do the coolest music. And I will be on Ronald's show on Mixlr as well. I'm going to be doing some shows with Ronald as well. Yeah, thank you for that, Greg. That's kind. Share, like, and subscribe. Yep. Yeah, we have a lot of fun. Like I said, right now the telescope is down. We had a malfunction, but we're going to turn that into a maintenance phase. And Friday is when our crack team, Marianne and Tara, go out to the observatory, and we're going to diagnose what's going on. And if we can't fix it on the spot, I have a few things that we can try. Then we are going to cart it down to Tucson. And while we're there, we're going to have it get a tune-up. And it's going to be kind of cool. Yep. All right, there we go. So it's mixler.com/ERRT-radio. That's Ronald, or ERRT Radio. So go ahead and subscribe to him. And go hang out with him, because that's a lot of fun. Yeah, Michael says, and come watch the night shows. Mark takes some awesome. Yeah, we have a great team here, and I can't, Skytra Livestream was me in the beginning. Okay, just me. I had a telescope out here, and I would invite Amanda Curran in, and she would co-host with me. And I literally had a dome on my front lawn. People go by and go, "What's that weirdo got on his lawn?" It looked like a giant minion, actually, from Despicable Me, to be honest. I even dressed it up as Stuart the Minion on Halloween, and man, you should have seen the people stopping taking pictures. Well, bottom line is that the telescope out west is the product of a number of people. Number one, the landowner, former Lawrence Livermore scientist, who said, you can set up on our land. And his wife graciously agreed to let us do that. And so we put a building on their land. And we couldn't have done that if not for the people who donated to our GoFundMe. And among those people and the movers and shakers of Skytra Livestream is Marianne Robb, who's here in the chat, and Tara Diulis, who is also, may not be in the chat. She wasn't feeling good today. But also, without the two of them, none of this that we do could happen. So that's why, even though I'm some big astronomer guy, okay, you can't do it without people that work with you. Okay, they don't work for me; they work with me. Okay, that's how I choose to say it. We all work together. And they happen to believe, like I do, that science is for everyone. So that's why I'm sitting down here in the corner telling you all about what you're seeing here and moving forward in this. I have a feeling that this is going to be a beautiful, amazing thing. Look at how big that's getting in the screen. Now you see the other one. Now you see Didymos and Dimorphos. Ronald says, what was supposed to happen on 9/24/2022? I think that's the date of the last stream. And I had set up a stream, but I forgot to delete it, Ronald. I made it clear that we couldn't do it because the telescope had malfunctioned on us. But we're going to fix it. It's all going to get fixed, you know. And again, from failures of technology, you actually move forward with new improved, and that's what we're doing, right? So that's important for us to do. Yeah. All right, so I'm going to step away here for just a few minutes, and I will be back very shortly, okay? So I'll be coming back. I'll check the texts and see if you left any messages. But until then, enjoy the music, and I'll be back probably just about 5 minutes at the most. Okay, I'll be right back. Well, I am back. Hey, welcome back to anyone who needed a break. Look, we can now see details on Didymos Dimorphos. Hey, Daryl. I see Daryl's here. Nice to see you. I mentioned, Daryl, that you were a little under the weather. And how you doing? You feeling better? Thank you, James. James says welcome back. Hi, Yuffie. How are you? Hey, look at this. This, as I mentioned, this right here, this is the first time in human history that we've ever done what you're seeing right here. We're watching this asteroid and this asteroid. This is a binary asteroid. This one here orbits this one, a few hours at a time. And I don't know if it goes that way or in or out. I mean, we don't know the exact orbit from looking at it right there, but that's crazy. Daisy and Zoe, that's funny. They say, what if the last thing the camera shows is the horrified look of the faces of the alien residents of the asteroid? Then I guess we will have violated the Prime Directive. Indeed. Yeah. You're watching history, folks. This is history in the making right here. Daryl says this reminds him of the Star Trek The Motion Picture, which is the first movie. I called it Star Trek The Commotion Picture. So, yeah, the uniforms were just sad. Thanks for joining us, Yuffie. It's so nice to see you here. Yeah, so there's a lot going on here in this asteroid right now. Charles Smar was kind enough to give us and tell you all some details about the asteroid, which is cool. Thank you, Charles. And Uberku, some time ago you mentioned that you thought you saw the companion, and you did. You were absolutely right. This is it. Yep, this is it right there. Okay. Boy, that's something. You can even see that the asteroid, Didymos, is actually not round. It is a chunk. Hello, Anahata77. That's Bonnie. Hi, Bonnie. How are you? Boy, look at that, huh? You'll notice the time up above, right? Time to impact is 17 minutes and 50 seconds. We're just closing right in, guys. Woo, this is so cool. Uberku says, I'd be impressed if it was a bank shot. LOL. Yeah, wouldn't it be funny? Hit Didymos and head off and hit Dimorphos and like billiard balls, knock them around. A.R. Lemieux says, hi, thank you for hosting this live stream. Oh, of course. This is a big astronomical event, as I mentioned. First time in human history we're doing this right here. And think about it. The result of this can help preserve human history, can't it? Yeah, I mean, if we see that we can nudge the asteroid a little bit, well, then we'll find that we'll be able to actually do this in the future with a dangerous asteroid rather than a test asteroid like this. I'm very impressed. Normally human nature is to try to solve a problem only after it's seen. We're trying to solve a problem before it's seen. And that's actually pretty cool. I'm very impressed with this. Okay, so oh man, it's getting interesting, isn't it? Right? Yep. Definitely interesting. Again, if it succeeds, it'll demonstrate how, for the first time in our history, we can protect ourselves from a potential asteroid strike. You know? The one thing that I think is interesting, is if this happens and if it's successful, then we will have a methodology, one methodology. There's other methodologies too. There are methodologies which say you could explode a weapon near an asteroid, and that the shock of that expanding debris can add all this tiny little mass particles that'll help push and nudge the asteroid. You could attach a rocket to an asteroid and have it just fire in one direction for several years in a row, and that would slowly push the asteroid a little bit, maybe a lot, not a lot, maybe only a few centimeters a year or every 6 months, but over 25 years that would be enough to alter its orbit to something safe. You know, look at that. That's just stunning. We're getting I'm getting nervous. What if they miss? Oh, that'd be bad. Looks like it's on target now, doesn't it? Looks like it's on target now. Daisy and Zoe had a question. Will this be archived so we can watch it over and over again? Yeah, no, this is a live stream. This is going to be on our channel forever. I purposely didn't use anything that they could argue was a copyright infringement. So this is it's from NASA, and you know, we pay for NASA, so this is okay. Well, hey there, Agenti Octo. How are you? Agenti Octo. Good to see you. Make sure you guys subscribe if you haven't. You know, that'd be great. You know, we do more than this. If you look at our channel, we usually stream the night sky and show gorgeous nebulae, and they show up brilliantly. And people, well, just ask the people here. The people here know what it looks like, and they tell you what it's all about. They love it. So that's what's going to happen. Hey there, Asher. Asher Real is here. Nice to see you. I'm more than happy to host this. I mean, when we first started, this asteroid was that size dot in the distance. You could not see Dimorphos. This is Didymos. This is Dimorphos. ERT. Thanks, Ronald. He says, this is the best place to learn about astronomy. Well, there might be others that are good, but this is the best. Well, thank you, Ronald. Sort of a compliment there. Hey, Marklin. I do not play Fortnite. Oh, Tim F., that's cool. I'm glad you're enjoying. By the way, for those of you wondering, up here it says ROI box within the DRACO field of view. ROI means region of interest, just so you know. Okay, and so that's the region of interest within the DRACO field of view box. And the DRACO field of view box is the dark gray box, and the black object there, the black square, that is the asteroid pair region of interest within. I have my cursor here, Donald. Yes, Donald's asking me. You can see the cursor now. Okay, I'm circling one asteroid, circling the little asteroid that is orbiting it. Hey there, Flavio Portolano. How are you? Great to see you, man. Thank you for coming out. Make sure you subscribe too, and click the notifications so you can know when we're going to go live with our big telescope out in Arizona. Ronald says, wouldn't that freak you out if the camera went out right now? Ronald, nothing freaks me out anymore. Technology can mess up from time to time. Don't we know that? Greg O'Brien says, what does space smell like? Interesting, space itself doesn't have a particular odor because when you smell, you have to smell molecules that activate sensors in your olfactory center in your brain. But this in the case of space, what they say is that the lunar surface, because dust got on their clothing when they walked on the moon, when they came in, they closed up, took off their uniform, their outfits, their spacesuits, and they smelled like burnt steak or gunpowder. And that was likely from the compounds getting bathed in ultraviolet radiation for billions of years. So in other words, space stinks. It doesn't smell all that good. Hey, Marvin. Marvin says, it smells like chicken. No, tastes like chicken. Lots of carbon. Yeah, that's true. Lots of silicate minerals, too, if you're looking at like a moon or something. Look at that. Now, we're starting to see the asteroid in much more detail now. We can see very clearly, we can see the outline and the shape of the asteroid. You can see areas that are convolutions and pits. And this is the little guy right there. And together, they make up this binary asteroid pair. Okay, so now, okay, we're waiting now. We're down to 7 minutes to impact, folks. 7 minutes. Don't go make a sandwich. Not now. No. Sit down. Where you going? Sit down. Watch this. Okay. Well, even Dimorphos is getting more detail on it now. See that? Okay, we're watching now. We're down to 6 minutes. So impact. Hey, Izabela. I see Izabela's made it. Izabela is like wonderful. She is amazing photo processing person who's in Sofia, Bulgaria, and she's also the one who generates all of our tables of contents for every stream. So, give her, let's clap for her. Very good. That's Izabela's here. Izabela Melamed, Sofia, Bulgaria, in the house. Yeah, the asteroid's gotten a lot bigger. See, look at it. I mean, I gotta move out of the way. I don't want to get hit by it. Didymos, this asteroid is actually under 1 kilometer in diameter, and the other one's even smaller. Wow, look at this. I gotta like shrink a little.
I gotta talk higher pitch now.
You can start to see some really interesting details now on the surface here. It's kind of interesting how we're actually going to visit this Stark asteroid. And we're going to witness the most incredible event in human history in just 4 minutes and 39 seconds. Okay, Asher asked a good question. What are the relative speeds of the asteroid and the rocket? If I got it right, I think that the rocket is approaching at 15,000 kilometers per second. So, I'm sorry, kilometers per hour. And that's pretty fast, and you might think that that's not enough to nudge anything if it's a tiny little spacecraft. To be like a fly hitting a window. How bad could it be? Well, the truth is that in space, because everything has momentum, everything has energy of motion associated with it, subtle changes can occur from strikes by meteors. And if we were to just pretend that this probe that's getting closer and closer, if they're not careful, it might hit it. This probe that might get closer and closer is going to do something crazy. It's going to end up hitting, and even though it's low mass, there will be an effect. There will be an effect, and that asteroid will be struck, and it will find itself getting some type of showing some kind of reaction to the strike, and that's exactly what they're looking for. Hello, Kathy Kornacek, how are you? And Richard Cisco, welcome. You can tell it's real because it looks so fake, and that's very funny. We're going to lose sight of this guy in just a short bit because we're going to end up going to this guy over here. Hey, Rascally Rabbit, what's happening? Nice to see you. 2 minutes and 30 seconds till impact. T-go, time to go. This is wonderful. Hey, Fantasy, how you doing? Good to see you. Keith, how you doing? What up? Two minutes. This is the 2-minute warning, folks. Two-minute warning. Ronald, don't say anything about the camera going out. Wow. So here it is, folks. All the millions of dollars spent to date on getting this to work and getting this out there. And it's about to happen. It's about to happen. 1 minute. 1 minute and 12 seconds. Izabela says, 2 minutes and the dinosaurs will be revenged. Yeah. Now you can see detail on the little guy. Holy cow, that is just beautiful. Oh. This is going to be cool. Hi, Leslie Latin Taylor. Nice to see you. Haven't seen you in a while. Kryptonite's here. How's it going? Good to see you. Just incredible. Wow. All right. This little guy looks like it could be a rubble pile. First time in human history, guys. 30 seconds. Less than 30 seconds. Look at that rock sticking off the top over there. Wow. Here it goes. And the end is near. That's a cool shot. Look at that. The last shot the probe ever saw. And it's done. Impact. 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 Micah Riggs asks a question. Where is all the little rocks that travel with it? Well, actually, there are no little rocks that travel with this asteroid. It's actually is a large asteroid that's under a kilometer in size and a small asteroid that was orbiting it. And we struck that little guy to see just what happens. Not bad. And there's the last strip right there. That's the last strip. Oh man, this was fun. This was really fun, guys. Really fun. I really like seeing this. All right. Yeah, like and subscribe. Check us out. Check out our other streams that we do. Gives you an idea of what we do. It's just incredible. Leslie Latin Taylor says, boom. Yeah. Very, very cool. Yep. Greg O'Brien says, what are those rocks made of? Well, you know what? That's the thing. This may have been a rubble pile asteroid that congealed and collected. And so they may be made of silicates and some ices, but mostly silicate rocks. There'll be some iron and nickel in there. Stuff that was made when the solar system was made. You know, very, very cool. Do you think, and Fantasy says, do you think this being a success will lead us to have more preemptive strikes? That's actually the exact reason for this mission whatsoever, is to test whether we can do that. And thus we will actually create a asteroid redirection program. And just so you know, this little asteroid did not get blown up. Okay, it got struck, and it undoubtedly made a splash of material which went up in the, it's called the exosphere because it doesn't have an atmosphere, the exosphere around it, and probably will orbit for a time and then come back and settle down. Some of it may reach the other asteroid, maybe not. Hello, Alanis Brown. And how do we know if it worked or not? Well, when the European Space Agency goes there with the next mission, they're going to be able to calculate the differences in the orbit. Because one of the things they did with this mission was calculate its orbit very precisely, so they know what Dimorphos and Didymos look like in orbit. So once they have that down, and they look at it again. Thank you, Leslie. That is so cool. Thank you so much. Once they do that again and revisit it I think it's going to be a couple years before it gets out there. And Charles says this is like hitting a bag of gravel with a rifle bullet. No big deal. Except that it's a low mass relative to the asteroid. And so we know that it actually we know that it actually will strike the surface. It probably won't cause a splash of too much material. Because keep in mind that over the billions of years, asteroids and meteors have struck it over time and splashed a lot of material around. Then it settles back down either on Didymos or Dimorphos, the two asteroids. So I think that's pretty interesting. But that's cool. That is so cool. And Donald Kunzeras did NASA give a confirmation. Well, the confirmation that it struck is right here. This red square basically says end of data. And that's because the very camera that was taking all these images is now destroyed. JM UFO, how you doing? Nice. Welcome from Brasilia. We have a lot of people that come in from Brazil. It's great. So, I want to say, Greg O'Brien also asks, wouldn't the laser work? Okay. We understand that laser light can drive things, right? Because there is energy, and that energy can be converted to motion. We know that. The solar sail concept works the same way. Ah! Jeez. That's scary. Okay. Well, we'll just let that play out. Okay. Yeah. Yeah, we don't need to see anything frightening like that. We've seen that all before. All right. So anyway, I'll get rid of this. I think this was the DRACO launch. I'm sorry, the launch. I'll just get rid of this here. We'll listen.
Asteroid redirection test has traveled millions of miles through space. Its goal: intercept and slam right into an asteroid called Dimorphos at a relative speed of 14,000 miles per hour.
We're targeting that small asteroid at a very fast speed.
Among the many challenges, Dimorphos is a moonlet, or a smaller asteroid orbiting a much bigger one called Didymos. DART is also using autonomous technology to make its direct hit. Since launching last fall, the camera system on board has taken more than 200,000 images to calibrate the spacecraft. All of it building up to a calculated crash tonight.
This mission has two parts. The first part is hitting the asteroid. The next part is actually measuring what happens afterwards.
Using telescopes on all 7 continents and in space, scientists will monitor in the coming days and weeks exactly how much the impact is able to shift the orbit of Dimorphos.
This is really not about destroying the asteroid or destructing it.
Right.
It's we like to call it like a small nudge.
A mission marking the first test in planetary defense, so that if an asteroid ever did threaten Earth, we might potentially knock it off its course.
We have the technology now to do this and find these objects years, decades, even a century before they pose an impact threat to the Earth. And that provides us plenty of time then to decide what is the best technique to prevent the impact.
Thank you, Vera.
And Tom, as I understand it, this mission is just one of several strategies NASA is considering to use against asteroids.
So they're looking at how they could deflect an asteroid that's coming into our lane, you may say. And one idea might be shooting ion beams or using a gravity tractor with another spacecraft to pull an asteroid off its course. Sounds like something from Star Trek, but they can do it. Even sending a spacecraft to detonate a nuclear device near an incoming asteroid to break it up on short notice remains an option. If all goes as planned, we should see impact this evening. It will not put this asteroid on a path towards Earth. We do expect to see images coming back from DART in the final minutes at about 1 per second. Should be a lot of fun to watch.
And it was, wasn't it?
Yeah.
Glad somebody's thinking about it. Tom, thank you.
And if it works, we play the Aerosmith track.
I know, don't want to miss a thing. Thank you. Yes.
Well, so that was a lot of fun, guys. I want to thank you for spending time with me and watching this whole thing play out. It was a ball. I had a great time with all of you. And I have a feeling that we're going to see more of the same, because they're going to be doing a lot more. They're going to be doing a lot more stuff in the coming weeks to try to understand exactly what happened and engage the impact and what happened, and I think that'll be really cool. So that said, that will be it for this stream, and I'm very happy you could join us. All right, and I want to thank you again for coming here. Zoop. Hey, there we are. Final little statement here. The SkyTour Livestream West, we had a slight malfunction out in the building, and the telescope went down. If you look at SkyTour Livestream, it's backwards, but so it says "Rikssport du the best," and that will be something that will correct. Marianne Robb and Tara Deulis are going out on Friday, and we're going to try some diagnostic procedures to see if we can get it to work. If we can't, then we've already got a plan, and people are standing by down in Tucson, Arizona, to repair it and fix it. So, and whenever we do that, we do an upgrade. So it's going to be great. All right. So until then, I will talk to you soon. Thank you guys all for being here, and we going bye-bye. So we'll see you later. Bye-bye.